Now we are seeing a shear force and bending moment diagram for overhanging beam. So this is the overhanging beam is given. So it is extended on left and right side also. So here two point loads are given at the ends, and in between we have a UDL. So for this we have to draw shear force and bending moment diagrams. So first of all, to calculate shear force and bending moment diagrams, we have to find out the reactions, because of this loading we'll get reactions at A and B. So that RA RB we have to find out here. So to find out reaction forces, we have to take the condition that the beam should be in equilibrium, such that sum of upward forces is equals to sum of downward forces. We have to take this condition. This is the condition number one, to keep the beam in equilibrium. Downward forces, so upward forces, here you will get reaction force at A, RA and RB. So uh, upward forces RA plus RB is equals to downward forces. We have 2 kilonewtons plus the total UDL value is 4 into 2 8, and plus 4 here. So the total here is 14 kilonewtons, that is RA plus RB. So this is equation number 1. And next condition, sum of moments about any point should be 0. Let us take sum of moments about D should be 0 to keep the beam in equilibrium. Then calculate the moments about D. So I am taking here the moments created by the clockwise forces as negative, or it is hogging moment negative, and the moments created by anti-clockwise forces about this D as positive, or this is sagging moment positive. Anyway we can take. So here I am taking, so this movements created by this clockwise forces about D is negative I am taking. So minus 2 into distance is 1 plus 2 3 plus 1 4, and here next RB, you will get a reaction force here RB multiplied by distance is so it is clockwise, sorry, anti-clockwise or sagging, it is positive. So plus RB into distance is 3 2 plus 1 3, and next so to get moment of because of this UDL about D, just replace this UDL as a point load. So total value of UDL is 4 into 2 8, and replace that UDL at the center. Why? Because this UDL, the effect of UDL pass to the center of gravity, so or center of this diagram or this space. So it is 2 meters, so center will be at 1. So I am replacing this UDL as point load, such that I am representing it as dotted line. So this total value is 8. So I am taking this in bracket, such that it is a total value of UDL replacing as a point load. So this will create a clockwise movement. So we are taking clockwise movement negative, or hogging as negative. So this distance will get it as 1 meter here, and this is also 1 meter here. So this is 1 meter, and so when you calculate movement here, so this will create a clockwise. So clockwise movement or hogging movement, we are taking negative. So minus 8 into distance will be 1 plus, this is 1 1 plus 1 2, and next here one more force is there, RA. So it is create sagging or anti-clockwise movement about D. So we are taking it is positive. So plus RA into distance is between these 2 points is 1. So it should be equals to 0. So if you write this one, it is minus 8 here, plus 3 times of RB, and minus 16 here, and it is RA. So if you have two unknowns, you cannot solve this equation. So we replace this RA as 14 minus RB from this equation number 1. So in the place of RA, we'll write 14 times, sorry, 14 minus RB, and this is into 1 is there, so into 1, so same value is equals to 0. And if you, we can write here, it is minus 8 minus 16 as minus 24 plus 3 times of RB, and sorry, this is plus, before it is plus, and the place of RA we have written 14 minus RB. So it is plus 14 minus RB here is equals to 0. So here it is plus 3 RB minus RB is 2 times of RB, and this is minus 24 plus 14 is minus 10, and if you send this side, it is plus 10. and here RB value will get as 5 kilonewtons, and from the equation number 1, if you see from equation number 1, RA value will be 14 minus 5, it is 9 kilonewtons. So we got reaction forces RA RB. So once again I am writing here, suppose I am writing here RA we got how much, 9 kilonewtons we got, and RB we got it as 5 kilonewtons we got. And let us calculate shear forces at different points to draw the shear force diagram. So let us calculate shear force at C, and let's define the shear force. So shear force is defined as sum of the forces to the right or left of a section or point. So I'm moving from right to left, so I will take sum of forces to the right. So, and sign convention for shear force. So suppose if at any section XX, the shear force is going clockwise direction, so that we'll take it as a positive, and if it is goes anti-clockwise, we'll take it as negative. Or simply for our problems, so if the shear force is going downwards, we'll take it as positive. It is going and because we are moving from right to left, so the shear force going downwards will take positive and upward will take negative. So such that here the to the right of C there is no forces, and exactly at C point 1 is acting, so we'll take that one, and it is going downwards means it is positive. So plus 2 kilonewtons is the shear force at C, and shear force at B is plus 2 from the previous value, and sum of the forces to the right means plus 2, and this is a minus 5. RB is as a point load acting at exactly at B, so it is going up, so it is minus 5 here, so it is minus 3 kilonewtons here. And shear force at A, if you take uh, so previous is minus 3, and here at this value is 4 into 2 is 8 here, that is it is a replaced value of UDL, so this is 8 here, and this going downwards it is positive plus 8. So this is the shear force just before A, so we can write it is uh, plus 5 plus 8 minus 3 is plus 5 kilonewtons. This is the shear force value just before, or just right just right off A here, and shear force at just left of B, if you see shear force at just left of B means, so just right is 5, and here all of sudden load is acting, so it is going upward means it is a negative, so it is minus 9, so it is a minus 4, so it is shear force at minus 4 kilonewtons. It is just left of A. So next, shear force at D, if you see, so to the right of D it is minus 4, so and from D to A no force is there, so it will continue, so shear force at D is also minus 4 kilonewtons. So let us draw the shear force diagram here, and don't take this 4 kilonewtons, why, because when you draw this diagram you'll understand here. So we got plus 2 minus 4 here plus 5. So when you draw this line, length of the line to indicate the length of the this beam, and indicate key points and A and B here also. And shear force at C we got plus 2 here, so plus 2 let us indicate with this, and it is a point load, will indicate with all of sudden means vertical line. So C to A no load is there, so it's continuous, and at B 5 kilonewtons is acting, so it is negative. So because of this negative 5 kilonewtons, the value here it comes to be minus 3. So next, from B to A we have a UDL, so it is increasing slowly, so we'll indicate with a inclined line. So just before right of A is 5 kilonewtons, plus 5 means, suppose we'll take this much as a plus 5. So here from this minus 3 to plus 5, so it will be like this inclined line, because it is UDL, so slowly increasing. So because here once again minus 9 is acting, so to the just left of A the value we got as -4. So from plus 5 to -4 is the shear force value here. So it is a vertical line here, and from A to D no force is there, so it will continue up to D and close the diagram. So if you observe this diagram, so the values are at different points are 2 kilonewtons here and here. So we'll take upside is positive and downside is negative. Down of the line is negative. And here, if you see at B at this point we have 3 kilonewtons, that is negative, and at this we have plus 5 kilonewtons, positive 5 kilonewtons, and it is negative or -4 or negative 4 kilonewtons, and this will continue up to here. And if you see the force here indicating the force acting at D, point load acting at D. So in our process don't take this load, so we are coming from right to left, so the last load should be neglected. It is like shortcut method to find out or to draw this diagram, or if you start from here, just you don't take this such that it will indicate the 2 kilonewtons here. So this is the shear force diagram for this given values, and let us calculate the bending moment diagram. So to draw the bending moment diagram, we have to calculate bending moment at different locations. So before that, we have to find out this location where shear force diagram is changing negative to positive or positive to negative. So why? Because at this location on the bending moment diagram, we will get the peak point in the parabolic curve. So we have to anyway we have to find out this location. So let us take this as a section XX, and let us take the distance from here is, so this distance we know already 1 meter. From this case, from the diagram we can say this distance as 1 meter, and let us take this distance as x here, such that we find out shear force at this xx and will equate to 0. So because from the diagram we know that shear force at xx is 0. So if you do that, shear force at xx is 0, and when you find out shear force at xx, so 2 kilonewtons is acting, so it is positive, going downwards is positive plus 2, and here it is going upward negative -5. And here if you replace this, so up to this distance, when you extend this diagram above, so we can write like this, and this distance we are taking it as x here. So when you replace up to here, it is we have taken 2 -5, and UDL is there. So the total value of UDL for this length is 4 into x, and it's going downwards means positive. So value of UDL is 4 times of x here. So it is 0, and so it is -3 plus 4x is 0, or x is equals to 3 by 4, or it is x is equals to 0.75 meters. So this is the distance of x. So x is 0.75 means, so the location of xx, the xx location, xx location from C is this 1 plus x. So what is this? 1 plus x is 0.75. So it is 1.75 meters is the location of this section XX from the C. So where the shear force is 0. So at this point we have to find out the bending moment also. So let us calculate bending moment at different locations here. Bending moment at C is 0. So we know bending moment is the force multiplied by the distance. So force here is acting at C, and we require moment at C. So moment of this 2 kilonewtons at C is 0. So we know bending moment definition. So force is acting like this. Suppose we require bending moment at O, and it is point A. Suppose if you take, and this is some distance x if you take. So when you require moment or bend moment from of this force F at O, it is a force multiplied by the perpendicular distance. So, and if you define the bending moment, means bending moment is defined as sum of the moments to the right or left of a section or point. So we take sum of the moments to the right of section or point here. So to the right no force is there, and at C2 we have 2 kilonewtons, but C to C distance is 0. We are calculating at C means C to C distance is 0. So bending moment at C is 0. and bending moment at B we want here. So bending moment at B is nothing but, and also we require sign convention. So suppose if a force is bending a beam or layers of beam upward, that is negative, that is nothing but hogging we are taking, so hogging as negative. And suppose if a force is bending the beam or layers of beam downwards, it is positive and it is called sagging. So sagging will take it as a positive bending moment. So bending moment at B because of this is, so this 2 kilonewtons will bend the layers of beam upward direction, that is negative direction. So it is a minus 2 into distance is between these 2 points is 1 here, and so the total value of bending moment here is minus 2 kilonewton meter. And bending moment at xx we have to find out. So before finding out a, between no key points are there, but we have xx section. So at this xx section we have to find out the bending moment. So to find out the peak point in the bending moment diagram, so if you find out bending moment at xx, so that will be uh, suppose this distance we already find out, x is 0.75 from the previous calculations. X value is 0.75 here, so x value here it is 0.75 meters. So if you find out bending moment at xx, it is it will create negative, so minus 2 into 1 plus 0.75 is 1.75, and it is positive, so plus 5 into, this is a 0.75 here, and this UDL we have to replace, and we have to first of all total value of UDL here is uh, this will create a negative moment, so it is minus, and the total value of UDL for this location is 4 into 0.75 is the value of UDL, and when you replace it this center 0.75 means this is 0.75 by 2. So uh, so when you calculate bending moment here, this will be, when you simplify this, bending moment at xx will be minus 0.875 kilonewton meter here. And next we have to find out bending moment at A. So bending moment at A we have to find out here. So bending moment at A come from the starting. So at A this it will create negative. So minus 2 into distance here is 1 plus 2. This is 1 and this is 2. So this 3, and next term this will create positive about A. So that's plus 5 into distance is between these two, this is 2, and next uh, here we have replaced this UDL, so here, so it is will create negative moment, so it is minus 8 into distance is 1 here. So when you simplify that, we'll get bending moment at A, the value as minus 4 kilonewton meter, and next bending moment at D we have to find out here. So bending moment at D come once again come from the starting. So here this will create hogging, that is negative, minus 2 into distance is 1 plus 2 3 plus 1 4 here, and it is positive, it will create RB will create positive. So it is a plus, RB means 5 kilonewtons here, and the distance is this 2 plus 1 3, and next we have replaced this, so this will create a negative. So minus 8 into distance will be 1 plus 1 2 here, and this RA will create positive, so plus, and RA value is 9, and the distance from here to here is 1. So when you simplify this, we will get this as a 0. So this is the bending moment value. So here we have to draw bending moment at these different locations here. So we got 0 and minus 2, minus 0.8, minus 4. So 0 to all minus values. So take or keep length below this line such that we can indicate all these minus values conveniently. So first of all, draw a line to indicate the length of the beam, and draw the different, indicate different key points here, A, and this is B, and this is C, and this is at this location we have section XX. So here if you see, bending moment C is 0 and 0 to -2, and if you see the bending moment diagram will draw with the help of shear force diagram. If the shear force between 2 points is line, between those same 2 points we'll draw inclined line here, horizontal line, inclined line, and if you have inclined line here, we'll draw parabolic curve here. So here we have B and C, between B and C we have horizontal, so we'll draw inclined line, and 0 to -2 means inclined line in downward direction. So -2 we have, maximum is -4, so -2 will take this much. So it is a inclined line here, and here it is 2. It is anyway downward is negative direction, upward is positive direction. So once again, no need to write negative here. So 2 kilonewton meter, and -2 to -8 means, so if you take this much as 2, and this may be the zero point 0.8, so, and -8 to -4, so this between these 2 points B and A is inclined, so here you will get a parabolic curve. So that curve should pass through this peak point, so that is the aim to calculate here this section XX distance and movement at this section XX. So for this curve, parabolic curve, we require peak point. So such that we have calculated. So at this peak point, we got movement as minus 0.875. So, and minus 0.875 to the -4 means, suppose if you take this is -2 and -4, maybe this much, and here it should be a parabolic curve between these 2 points, such that we should get a peak point here, and this peak after this it should be, so like this. So this total is a parabolic curve here, and -4 to 0. So here we have horizontal line, and here we'll get a inclined line here. So it is an inclined line between these 2 points. So this is the bending moment diagram. So total is negative we got. So 2, and this is 0.875 kilonewton meter, and this is a 4 kilonewton meter. Anyway, it is negative direction and 0. So this is the way to calculate shear force diagram, and to draw shear force diagram and bending moment diagram for the given overhanging beam, two sides overhanging with the given point loads and UDL value. So for more videos, please subscribe and activate bell symbol. Please like it, share it with your friends, and don't forget to subscribe. Thank you.